After this video, I promise you won't look at rainbows the same again. So today I just want to talk a little bit about color. And honestly, I think this is a really good discussion for any student to have. I'm going to just start jumping right in with the difference between frequency and wavelength. You probably have heard these words before. Well, they're actually inverted. So if you have a high frequency, as you can see here, it's a short wavelength, and a low frequency is a long wavelength. What does that even mean? Wavelength is defined as the crest-to-crest motion of a wave. In physics, that becomes a very important thing. A high frequency would have a short wavelength. As you can see, it's a pretty short distance to get from the top back to the top. But another way to view it, a low frequency would kind of be something like this. It's going up, it's going down really slowly, where something that has a high frequency is up and down and very, very, very choppy. Well, what does this have to do with color? Well, as you can see here, this is the electromagnetic spectrum, which is a bunch of different radiations and a bunch of different frequencies, ranging from radio waves, which are relatively harmless. And we're getting hit by radio waves right now, and we're absolutely fine. On the radio, you're good. Microwaves, we're good. Infrared, so I'm going to write here. Obviously, it has to do with red light. All the way, I'm going to do infrared, and all the way to ultraviolet, which I'm going to call UV. Now, you've heard of UV radiation before. It's because that's how we get sunburned. That's not necessarily a good thing. So in this very small area of visible light, we have the entire range of colors. And as you can see, red would have a very low frequency, high wavelength, and ultraviolet would have a very high frequency, a short wavelength, making it more dangerous for you. And again, this chart kind of shows it. Low wavelength numbers have a higher energy, 2.75 to 3.26, versus red at 1.65 to 2. Again, that's why you can put infrared goggles on and see at night. It's not a big deal. Ultraviolet radiation is something a little bit more dangerous. So this is really, really cool stuff. But what does this have to do with chemistry? Well, there's something called the photoelectric effect, which I know a few of my students really wanted to get into. And really what the photoelectric effect is that light, when given enough energy, frequency specifically, you can actually, again, this is an atom of this metal, actually get electrons to bounce off the atom. So for example, something red, as you can see, kind of weak. Like we just talked about, red doesn't really have that frequency. It's not going to do anything. Yellow has a little bit more energy, as you can see, and you might get one to jump off. Blue has a little bit more energy, a little bit more choppy, and you might get it to go a little further. Maybe you'll get another one. The purple, which has a very, very high frequency and a lot of energy, honestly, you might get all three to go. You're going to have them with a lot more energy. So the further these electrons go, the more energy they would have. And that's a little bit of a way to make a connection with chemistry and the photoelectric effect. So this is going to be a little bit more important later on. Again, I'm just going to show kind of the colors so you can see that it's getting more and more wave-like, like up and down. And again, I hope you enjoyed this short video on color. So maybe the next time you see a rainbow, realize that there's a lot more going on with color than you might have thought. Okay? Have a good rest of your day.